we need new materials. We can't solve the problem with what we've always used. You can't lose the functionality. None of us are going to move away from products that aren't convenient or aren't safe or don't arrive on our doorstep the way we want them. So we've got to start there.
Hello. Welcome to the Good Garbage Podcast. My name is Ved Krishna. My primary reason for existence has been to find ways to leave our wonderful planet cleaner. We will be speaking with material innovators, creators, and propagators to learn from them how we can build for scale and towards a regenerative future. Their stories will help us answer the big question, what is good garbage? Hello. Today I get to speak to Mark Lapping, the CEO of Aquapak. Mark has had such an interesting journey. We get to speak about my time and experiences in Scotland that were so formative for me. He grew up in Scotland and also served for a year or a little over in Africa, which really guided his journey. Mark has worked with a variety of global packaging companies before taking the entrepreneurial plunge to build Aquapak. Aquapak is building and creating great barriers for flexible packaging from biopolymers. And I saw the products myself in action when we were in Rethinking Materials in London. This is a fun and wide-ranging conversation, which I thoroughly enjoyed, and I hope you will too. Hello. I'm joined today by Mark Lapping, the CEO of Aquapak, which is a UK-based company which works on numerous magical products. And Mark, of course, you may know that I happened to meet Julian and John, who were next to our stall at Rethink Materials. Mm-hmm. And I was so excited to see all the products that you guys were bringing out. So thank you so much for joining the show.
My pleasure to be here, Ved. Very good to meet you and good to be on the show.
Thank you. So let's start in the beginning, because we did a bit of snooping, but we couldn't find so much about your growing up years. And, we know that you grew up in England, probably. But tell us about the impacts that your growing up had, so that, that impacted your life today and the choice of the contribution that you're making today.
Great start to any interview, yeah. But add a bit of context. So, no, England, a wrong assumption. Much better than that. Scotland is where I was born and grew up. Although I've lost the accent, I have lived most of my life down in England. But yeah, my dad.
That's not okay though. You have to bring back the Scottish accent.
Don't worry.
Come on.
I could if I wanted to. But I go back there to watch sport. I support them in every sport. That's guaranteed. So yeah, watching England's always a tough one. That was my upbringing up there, and in the UK, let's call it that. And my father was a school teacher, so I moved around quite a bit. But I guess what was formative in my background that sort of brought me here was a sort of fundamental awareness of the environment we live in, be that both the built environment and the natural environment. And just I was lucky, I was pushed into the countryside at a young age, taken on some great holidays, had some great traveling experiences, and saw a great diversity of places, and also the ecosystem and how it sort of interacts, albeit at a pretty basic level. And that, and then my subsequent sort of studies, always interested in the sort of planet and the geography of our planet, and how all that pieced together has led me to where I am now in terms of trying to do something impactful and positive for the planet in terms of how and what we use in our everyday lives. And it really did sort of come from those fundamental beginnings.
Superb. So I have actually 3 stories for you from Scotland, my experiences in Scotland. Mm-hmm. So when I was 16, and some of them may resonate with you, and that's why I'm bringing it up. When I was 16, there was a consultant who was my father's consultant, and he challenged me to go to something called Ridgeway Adventure Academy, north of Inverness, in a small little island called Ardmore. Mm-hmm. So I spent 2 excruciating weeks literally trying to live off the land, and it was amazing. I think a lot of my work today is impacted by that, because one of the things they taught me very clearly was leave people and the planet better than you found it. People and places, rather. That's one of the principles they lived by. The second was I was in Glasgow, and this brings me back to the accent. And I was in Glasgow one time with my ex-wife. I remember we were having a meal in a restaurant, and the waiter came and said something. I still don't know what he said, but I ordered something and it was okay. But I couldn't understand a thing.
Salt and sauce?
Thick an accent. Yeah, maybe something like that. And then my father actually went to for paper technology, as you're very familiar with paper and packaging, to Robert Gordon in Aberdeen. So we had a lot of connect there, and some of his friends became my friends. And I was studying in England later, and then I visited a lot, especially Aberdeen and Edinburgh and southern parts. Spent a lot of time there, but it's great memories of Scotland for sure.
Yeah, no, it's a wilderness, some of it, as well as some great cities. But I think a lot of people in the UK don't realise that they've got this wilderness on their doorstep, and nearly 800 islands off that west coast. Similar story for me. I actually did a stint in the army before I went in my business career, and we did an exercise similar to yours, and that's why I'm impressed. You lived off the land north of Inverness for 2 weeks. I'm not sure what you were eating, but we did the same, but for less than a week on an island called Ulva off the west coast, and it was a pretty wild but amazing experience. And yeah, exactly the same. Leave the land in the same or better shape than you found it.
Yeah, it was mostly mussels and snails, whatever we could put in that seawater to boil in the end, because it was really amazing. Because even at that time, of course, we had no GPS. I'm talking very, very early 90s, 91. I remember they would wake us up at 11, start getting dark. This was July. And they would wake us up at 1:30 to climb a mountain at 1:30 a.m. Because from the other hill, they would provide us the Morse code for the grid reference for where our breakfast would be the next day. So, that was the only way we could find food apart from mussels and snails and boiling it in seawater. So it was amazing. But I want to go to your geography roots more. What attracted you to geography, and I'm sure that impacted your choices as well.
Yeah, I think geography is an interesting subject because I think in some areas it's much maligned as being very general. But I think that general aspect about geography, it sort of connects so many things. You have to sort of start with the fundamentals of geology and understand how our planet's constructed, and then build off that as sort of how life has formed and the ecosystem has the amazing ecosystem that has been created around that. So I think what a geographer does is sort of look at the problem and the solution. You can say, hey, don't build that dam because there's obviously having a negative environmental impact, but hey, don't build that dam because in 20 years the river's going to silt up and X and Y could happen to your population, and these could be the social and economic impacts of that. It's sort of a way, I guess, a geographer is trained to think. And I just always loved the environment, but as I said at the beginning, all the aspects of the environment, both the natural and the built environment, and it's how all those factors interconnect. And I guess that brings us right to the present time of some of the big existential threats that we as a human race are facing, of how we actually coexist, or 9 billion of us, or we're getting that way now, can coexist on this planet, that we're rapidly warming up, and how all those factors are interconnected, and the challenges we face. And at a very sort of focused and micro level in that challenge, we're going to be talking about plastics and the specific how we use those and the impact that those have on our broader environment.
And why the army? What attracted you to that?
Similar to you seem to like getting up at 1:30 in the morning and yomping up hills, albeit you didn't sound like you had much choice in it. I was a volunteer. But I just love that sort of challenge. If there's a mountain, I'm going to go and climb it. And taking on, and there's a straightforward analogy there to what I'm doing now is, doing something brand new, particularly in the material, is a massive challenge to bring a new technology to market. And that's the same in my life when I'm not at work, is taking on physical challenges like that. So that was one aspect of it. Two is, I think, I was lucky enough to join the British Army. I think you get trained half of your life. So you'll spend your life training, you learn some amazing skills, you get given incredible opportunities at a very young age. And you get out what you put in, basically. So you can have a fantastic time, and you can also have a short career or a long career. So I chose a short one, did a 5-year stint, but had some amazing experiences in those 5 years, which I don't think I would have, or I know I wouldn't have got if I hadn't done it.
You are a true Scot then, because when we go around, and I don't know how much I'm sure you're a little familiar at least with the history of India. And of course, I spent a lot of time on the Indian mountains, climbing and hiking and rambling, whatever you may call it. And the beautiful thing about the Indian Himalayas is that you'll always find this amazing structure that was built by a Scotsman at some point. And it was mostly Scots. It wasn't the Brits. It was mostly Scotsmen who were going on their horse, and there's some story around it, because this was it was a remote little village, and you'll find this beautiful bungalow overlooking the white-capped mountains, and it's just so beautifully made. And the story would be that there was a lone Scotsman who came here, liked this vista, and created something like that. So you clearly have that Scot in you then.
Well, certainly the wanderlust, and I know our histories are very interconnected because my dad was actually born in India for exactly that reason.
Oh, wow.
Yeah. So,
did you ever visit?
No, and sadly, he sadly died this year, but we always talked about going back, but we never made it. So
well,
one day I'll do that. We'll get around to that. But no, he instilled in me sort of that desire for travel and seeing the world. And I think, a lot of the history of Britain and the fact that we did, shall we say, go to a lot of places and create this sort of enormous empire at the time, was the Scots that did the work. That's for sure. I think it's in the DNA.
Yeah, so now it's mi casa tu casa. You can always come to India, and we'll find a way to make sure that you find the roots of where your father was, and stuff like that. So you have that offer from us online, committed. So
I'll be taking you up on that.
Recording of this now. Okay, so the other thing I wanted to pick up on before we switch to the core subject of Aquapak was your year in Africa. That sounded beautiful as well. It was Save the Rhino International and traveling across Africa. How did that happen, and how did that influence your life?
You said you hadn't done any digging. You seem remarkably well informed. That was again through various connections, but it was more. I love Africa. Let's start there. Africa gets under your skin. If you've ever spent any time there, proper time, and I'm not maligning anything here, but I'm saying away from the beach and just a holiday, just with the people there, they're just very infectious. They make fun and they enjoy and they have smiles on their faces, regardless of all the challenges that get thrown at them. And they teach you a lot about life and about how lucky we are. Just things we absolutely take for granted, whether it be a tarmac road, or turning a light switch on, or going to the shop and being able to buy whatever food choice we want, let alone the climate and some of the challenges that throws up. So it just always got under my skin, Africa. So when I had the opportunity to travel down it by vehicle and actually again try and make a positive impact by procuring and then donating a vehicle for Save the Rhino International, it just covered a lot of bases for me. Is when I left the army, it was just a great sort of project and adventure to do, but ending up actually being able to hand on something useful, which is what we did. And at the time, the rhino was a desperately endangered species, and sadly it's only got worse. But I'm pleased to say that at least one of those species is still clinging on in the wild, but it has been shockingly poached. And that challenge continues, and as most of the people are well aware, it's very close to extinction in Africa because the value of its horn drives a black market that makes it worth the while for people to pick up a Kalashnikov and go and shoot them, because if you've got nothing, that's a very tempting offer when someone's offering you that sort of money. So it's totally understandable, sadly, why it does happen. But if, again, I think it's sort of akin to the environmental challenges that we have. If we as a human species can actually club together and collaborate around what to most of us seems an obvious cause, we can stop these things from happening. But sadly, that continues because of the market for the horn in certain parts of the world. But I played a very, very small part in trying to assist that project. But the Save the Rhino work continues, and those guys do a great job.
Yeah, as it turns out, my sister-in-law, who was born and brought up in Kenya, worked. I don't know if it was the same NGO, but she definitely worked with rhinos and elephants, and then the lion guardians was something she was instrumental in. Worked with vultures, and now works on something else. But again, super involved in conservatism, and basically they love Africa. My brother and my sister-in-law, they live there, and they absolutely, you're right. It's like I asked them to think about shifting during COVID because they were both hospitalized. I said, we won't be able to get you out if something happens. It was just like, there is no way we are shifting out of Africa.
Yeah.
And as it turns out, I was in Madagascar last week, so I do know a little bit of what you're talking about, but not as much.
Now there's a place I want to go. That's an amazing place.
I need to spend more time there. A friend of mine is based there for the next 3 years, so I told him I'm coming back maybe next year, and spending more time exploring. It's just such amazing diversity, because like 90% of the habitat there is nowhere else in the world. So it's so cool to see some of the things that you never see.
I mean, the Galapagos gets a lot of publicity, but I don't know why we don't talk about Madagascar more, because for the same reasons.
Yeah.
But I've been not lucky enough to go yet, but it's on my bucket list, that's for sure.
Perfect. So, okay, let's segue to packaging, because there's this huge line of stuff that you've done. The one that I have on my notes is Coveris, and I don't know how good the pronunciation is, Paragon, Mondi, Southport. And how did this happen? How did the move from saving the rhinos get into packaging? Because that's again a different line altogether. And then talk to us a little more about the things that you learned in these different companies, because they are all different in some way or the other.
Yeah, how it happened is more by chance and design. I got offered a job in a paper business as I came out of the army. I had a good friend who worked in a particular business, and I just got introduced to someone and ended up working there, and so that was really formative. I had made a choice that I wanted to be in something tangible. I was quite wanted to get into manufacturing, just because I thought there were good opportunities there from a sort of growth and management career opportunities, but also it was nice to physically actually pre-producing something and having a product to work with. So that was, I found myself in the world of materials and paper, and then that led into packaging. And they say once you get into that world, you never get out. And so far, I'm living proof, although I've moved through the supply chain slightly, which is to where we are now with Aquapak. But it was a good introduction to what we take. If you're an everyday consumer, you don't really think about. But suddenly you find yourself walking down supermarket aisles and taking a real interest in how everything's packaged rather than what's actually in the product. Sadly, I've done a lot of snooping and holding my family up. I sort of turn stuff over and feel it and look at what the recycling label was and mutter about greenwashing or green lighting, and then move on down. So it's not a career I would have planned, right at the beginning of, when I was in education, but it has led me to where I wanted to get to, if that made sense.
Yeah, makes a lot of sense. And on both aspects, I totally echo your thinking. I came into the industry literally kicking, screaming, because my father had started a company. He had lost interest in it and it was going down. And I came back just to say, okay, I'll help my father, maybe even wrap up the business. But, but as you know, once it takes you in, it's kind of difficult to sort of come out. And of course, that's maybe 14 years of kicking and screaming. And I realized, I can do a lot with this.
Yeah.
That's how the evolution started. But yes, I couldn't leave the industry. And the second, totally, my wife, again, like I'm literally, we get a gift and I'm more interested in the packaging. I'm like, okay, let's check the paper. I said, this is really cool. And, they've really done a good job out of this. So it's very similar to you. I think all us packaging people wander the aisles looking at the packaging instead of the product inside it. And my wife doesn't still understand it. Like I'm not shopping for groceries. I'm looking at the packaging and what's happening there.
You are. No, I don't think my wife's quite as understanding. I think she's had enough of it. But no, it's not for everyone. But it's a fascinating topic as we're going to get into. And I didn't really answer the other half of your question earlier. I've been lucky. I've worked for some very big multinationals. I worked for Amcor. Just even when they were in paper, they've obviously now got into flexibles. But when they were really beginning to grow as a business, so I saw that perspective. Mondi the same. When they first divested out, they were. You forget Mondi was the small subsidiary in the giant Anglo-American corporation, and now they have a bigger market cap than Anglo-American.
I did not know that.
Yeah,
that's news to me.
And so they divested out of South Africa because they were a resource company, but they were all in wood, and the rest of the company was in mining. So they sensibly split it off in the late 90s early 2000s, and so they've successfully grown. So when they landed in Europe and did their first acquisitions in Europe, I happened to be working in one of those businesses. So that was a fascinating experience, in seeing how those guys thought about the overall market and set about homogenizing the various acquisitions they had bought and then growing the business. And then I moved to a smaller business, which was Paragon, but founded by a brilliant entrepreneur who set the business up. And I took over the business from him, and then we sold that business to a private equity group. So then I had a whole different set of experiences with them, and then we were then merged again with a bunch of other packaging businesses to create Caveris. So I think that's sort of a microcosm of the story of packaging in many ways. It's a hugely fragmented industry. There are a lot of small players. It's geographically fragmented, and it's fragmented by product, and so there's a lot of merger and acquisitions activity always, and there's a lot happening because it's such a ubiquitous product. Everybody needs packaging, and it might only be 1 or 2% of the actual product price of what the consumer pays, but that product can't move or get to where it needs to be or be used by a consumer if the packaging isn't right. And so it's something that, like it or hate it, and there's a lot of press about packaging, negative press about packaging. It's something that we all need if we want to carry on the lives and the convenience that we have now. So it's, no one thinks about it, but it's absolutely fundamental to moving stuff around and being able to consume stuff.
The Good Garbage podcast has been brought to you by Paka. Paka has been creating solutions in the food packaging, carry, and service space. Paka utilizes sugarcane residue and upcycles it into amazing products. Their latest offering is a compostable, flexible packaging solution for the chocolate and confectionery industry. The products are available in the Indian subcontinent and in North America now. Paka is also building an end-to-end solutions for customers in the food service and delivery space. For any query, do email at connect@paka.com, and Paka is Pakka. Now, back to the show. To the main meat and potatoes of this conversation. So you are in this comfortable job where you're leading companies, and you decide to pivot and you get into a startup mode. How did that come about? How did Aquapak actually emerge, and what was the thinking, and why did you take this getting out of comfort zone? Like, knowing very little about your personality, I can kind of deduce why because of the climbing mountains. But but you tell me, how did that happen?
Yeah, no, I'm glad you started there because that sort of sums it up. If I see a challenge, whether it became a physical one or a business one or any other one you want to think of, it always fascinates me and interests me. And some things just get under your skin where you see, I'm not just going to talk about that or watch it. I actually want to get involved in it. And Aquapak was a slow burn for me because I first saw the product while I was running Caveris in the UK. The technical director, he had an open brief to go and bring new materials in, and he just walked in one day, brought in what looked like a standard piece of flexible packaging film, put it in a glass of hot water, and it dissolved in front of your eyes. And then he pulled out another piece. He said, "Go and try and put your finger through it." And I couldn't get my thumb through it. He said, "Good, isn't it?" And I said, "Yeah, this is really interesting." He then told me the functionality of that material, that it was a great gas barrier for all gas. It was an oxygen barrier, a grease barrier, a fat barrier, and a petro barrier as well. And it was 4 times stronger than HDPE. And I went, okay, now I'm really interested. And it had great clarity. And that's where I first saw the product, fully dissolvable hydrophilic polymer that can do the same job as a hydrophobic standard polymer. But with great functional characteristics beyond what a lot of polymers have. And as a packaging guy, a material guy, you start thinking of all the possibilities of how you could use that material, either on its own or in combination with other products, to design stuff which is useful and functional in the everyday world, but has none of the jeopardy that you get with other polymers at the end of its life. And we now sort of need to talk about how packaging is made and how it's evolved to how it's made. But to answer your question, I'm sure we'll get onto that, but answer your question directly, that's what piqued my interest about Aquapak. Now, I then very quickly found out that the business was still at its early stages. This was very much a lab material, and we still had to go through all that fundamental R&D work in order to get the product actually running consistently and stably at scale and work through that. So there were a huge number of challenges ahead, but it got my interest enough where I showed a direct interest in the company, met the chairman, and the chairman said, "Hey, why don't you come and join us?" And I don't usually need 2 invitations to take on a challenge like that because that's the way I'm wired. And the other thing that was very much a subtext, and it's not just me, I think it's everyone that works in Aquapak. We all have a desire to, albeit, we don't want to overcook this, but I think everyone wants to do something positive. Everyone wants to make an impact or to leave the world, if they can, in a better place than they found it, or have a way of at least contributing to that. And I think all of us are here because we absolutely firmly believe in what we're doing, and we just want to make things better. They're never going to be perfect. I think everyone's striving for perfection is always going to be disappointed. But if you can do stuff that's better than what you did yesterday, or you can produce materials which are better than stuff we've made before, just getting started and trying stuff, it makes a positive impact. And I think that's what drives us all on. So I didn't need 2 invitations to give it a go. And 5 years on, I'm still here.
Super. So how long was it from the time you saw the material to you chucking your comfort job and moving
3 years?
Well, it is a while.
2 or 3 years.
It did take a while to wrap up what you were doing.
Yeah, no, I watched it for a while. Yeah, I watched it for a while.
Whether this was real or not.
But this is also the challenge for everybody, right? Because not everyone's in a position where they can do that or want to take that risk, because we've all got houses to heat, lives to live, children to look after. Not all of us, but I was in that position, a lucky position where I did. So it's not just you're making that calculation for, and maybe it was a risky move. I mean, in terms of a career, but you only get one. I don't want it to come out with too many cliches, but you only get one shot at your career or one shot at doing stuff. And I wanted to give it a go. Really, so I wanted to try and do something that was ultimately positive and impactful. And of course, you want to make a successful business out of it at the same time. And Aquapak has all of that potential.
Well, the good thing is with your solid resume, you always have somebody who would be wanting to have you back in a regular packaging industry. But just to understand it, your career a little more, I presume you must have sold all kinds of packaging in this time, in time, because
Yeah.
I know what, like Mondi can make craft, and there are others that may make flexible packaging. So I guess it was every, like, paper, plastics, and everything in between. And how did that was that something, was it something on your conscience as well as you were making this shift, or did you think that's done, but I have to also evolve further?
No, it was, it was on absolutely on my conscience, because when I first saw this material we produced at Aquapak, which is called Hydropol, there was this dissolvable film which is highly functional. Immediately my mind raced to all the different iterations and all the different formats you could use that in, because I had that experience, exactly that. And ultimately packaging is a combination of different materials that give you the functionality you need in order to get our products that we package safely and conveniently to the consumer, with lightweight, using the least amount of energy, but maintaining the product integrity, communicating all the information you need to communicate, so that the consumer is 100% happy with what they're receiving. And we have done, and I count myself in this as a packaging industry, a fantastic job over 60 or 70 years of evolving these materials to make fantastic lightweight packaging, which is hugely convenient and functional. So it's not something you're going to unwind overnight, or you even want to unwind overnight. But we've got to find solutions to do that, so it's not just a linear economy and using it all the time. So when I first saw that material, and being a packaging guy, you think, wow, there's so many possibilities here. And then you start getting excited, and then you get pragmatic about all the steps you need to do to actually get that to work and bring a new material to market with all the inherent challenges, because no one had done it before. But you still get excited and think, we can do this, and we have done it, and we will continue to evolve it and take it even further than we've already done. And it will have a positive impact on the way we use materials. Not because it's trying to replace or supersede anything, it's not necessarily better than anything, but in combination and collaboration with other things, it enables you to do stuff you can't do without it. So it's that enabling technology which just gives packaging designers another tool in their toolbox that they can just use and deploy to design highly functional products that can be either recycled, organically put into the organic waste stream, or in worst case scenario, if it needed to, in the natural environment, it would fully biodegrade and leave no trace. So that's why I'm at Aquapak.
Yeah, and as you call yourself, a polymer nerd, so I'm sure the
Well,
Aquapak guys were very happy to have such a wide spectrum of experience with different packaging, and on top of that, a polymer nerd amongst them. I'm sure
Well, I,
that
I
helps.
tell you what, if I'm a polymer nerd, then I'm surrounded by utter geniuses, because I'm very lucky to work with some extremely clever people,
Well, I did meet your
chemists
CTO, and he
and
was clever.
scientists. Yeah, who really are. I wouldn't call them nerds, but they really know what's going on, and they know obviously the chemistry of our own product, but also the chemistry of how that combines with everyone else's product, and the impact that has both on their affinities, so you can process them together, but also the functionality, so you're creating stuff that the world wants, and then how they break down. And I think that's the fundamentals, back to the point of how did packaging evolve. It evolved for a reason. We can't ship everything around in metal and glass, which is where it used to be. And not in all parts of the world, but in several parts of the world, we have evolved from a very localized seasonal structure. If you just eat, what you can buy on the local market, into this fast-moving consumer goods world, and that is an enormous supply chain, as we all well know. So you have to have packaging, but we have moved from glass and metal, which are obviously easily identifiable, easily sortable, easily separable, and therefore easily recyclable, into a whole range of complex materials, particularly polymers, which aren't easily separable or easily recyclable, but we've created fantastic lightweight packaging which does a fantastic job for us as consumers. and we're not going to be able to fully rewind that clock. And I don't think we want to, because just look at the energy use that we would need if we didn't have all that lightweight stuff. Now, there is a fundamental question about the lifestyle we lead, for sure, and there are certain items which are completely overpackaged. Easter eggs is a good example, which you could just eliminate, but those are those low-hanging fruit aren't going to change the system. They're going to make some impact, but a relatively minor impact, and we're not going to go back to, I believe, changing everyone's lifestyles, because we're wedded to that lifestyle of convenience. So how do you make packaging work within the current supply chain? And that's where we at Aquapak fundamentally believe you need new materials to help unlock those challenges.
And that takes me really well, because I've been wanting to learn more myself, and I'm sure many of the listeners want to know more about PVOH, PVA, and the base substance that you guys use. Where does it come from, and why PVOH and PVA? So take us through the technicalities of the base material.
Okay, so it's still derived from oil. I think that's the first thing to say. And it's basically a petro-based material that behaves like a biopolymer. The thing that makes that possible is a hydrophilic material, so it breaks down in the presence of water. But it starts through that cracking process. You then create vinyl acetate, and from vinyl acetate, as a third step, you can create polyvinyl acid, polyvinyl alcohol, and that's what PVOH is. Now we are actually developing our own, and we've got the IP registered, the IP on this now, but our own bio-based form of polyvinyl alcohol. The chemistry won't be an exact match, but it'll be very close, from a food waste source. So ultimately, and it goes back to getting what I was saying about getting started, and also something better than it was yesterday, keep improving. Our long-term vision, and we're still talking 3 or 4 years down the track, is we'll have a bio-based form of polyvinyl alcohol. But right now it's still oil-based. But even as an oil-based material, it won't cause you any environmental jeopardy, and it can really help in creating the circular economy because of its inherent characteristics at end of life, in that it dissolves. That's its key attribute, but it has this high functionality if you can process it. And that's really where Hydropol and these brilliant chemists that I work with have come in, is we've been able to create and formulate from a base raw material, as you say, PVA, PVOH, which exists. There's probably around 8 million tons being produced annually. Most people know it as the film around their dishwasher tablet or the detergent tablet that they use in washing machines at home. That is a form of it. Now, that's a form of PVA or PVOH, which is combined with other materials so that it can be processed. So it reduces its functionality because it's a co-polymer. What we've been able to do is not have to co-polymerize the PVOH. So if you like, it's pure PVOH. What you do is then keep very high hydrolysis, so above 92% hydrolysis. It's Aquapak's IP. So we have high hydrolysis PVOH, which gives you high functionality, but it also gives you all the environmental benefits that we have, or end-of-life benefits that you have a fully dissolvable material because it's not a copolymer. There's nothing else in there, and you can then use it for a whole range of end-of-life. But predominantly because it dissolves out, you can separate it very easily from other materials. But if you wanted to biodegrade it in an organic waste stream, it would fully biodegrade, either in composting or anaerobic digesting, or even in the natural environment.
That's amazing. So two things. One is, of course, are you then subject to the price fluctuation as it happens with plasticizers and oil? And the second is a more specific question on what do you mean by high hydrolysis, and how does that impact the functionality?
Well, yes, we are subject to commodity prices because it's ultimately wedded back to that feedstock, and it's also there is, as I mentioned, a 3-step production process. So it's a relatively high cost process in order to end up with polyvinyl alcohol, and then that is traded, and you can track that, the indexation on that on Platts or ICIS, and that's what we do. Because of that, it is a more expensive polymer. So that's part of the challenge. However, going forward, the bio version of that I mentioned, we're actually looking at, and we still got to complete the job. So we're working on this, but we'll do that through a 2-step process. And as I said, it will be made from a readily available food waste source. So we need to work through how the economics are going to work on that. But like all these things, when you introduce a new material to market, the price is going to be different. You're getting a whole different level of functionality. You're getting a whole different level of end of life capability, and the pricing is set based on what the material does, and that's where polyvinyl or hydropol is. But polyvinyl alcohol is. But you can trace the raw material before we get hold of it, and then do what we do. And just a little bit more about the IP. The hydrolysis is only part of the equation. What we do is we formulate it, and we are right. We have some plasticizers, but we formulate different blends of polyvinyl alcohol. So different producers have their own blends, and we have 4 or 5 key producers in the world. No 2 blends would be exactly the same, but it comes in its raw flake form. So we blend those together, we add some plasticizers to those, but we then put it through a reactive compounding process. So our IP is half based on the actual chemistry and half based on the actual process by which we manufacture it, because there's a reaction taking place in the compounding vessel. And controlling that along with the actual formulation is what produces hydropol. So the IP is written on both aspects. We don't need to go into too much more detail on the IP.
No, of course. but just from a layman's perspective, if we look at base level, the physical manifestation of hydropol, versus if one was to buy a PVOH direct from an oil company, how would the physical manifestation differ in terms of functionality?
Okay, that's a relatively easy one. In terms of, we don't need to go into too much depth. So you buy it in flake form. So it literally looks like a snowflake, if you like. That's obviously, it doesn't melt in your fingers like a snowflake, but it looks and feels like that. And by the time we've actually blended it, and then you add you then put it through the reactive compounding process with the plasticizer that I was mentioning, you then get a molten form of it, and then as a molten form of that comes through the screw and barrel, we then pelletize it. So that's the key differentiator here with standard polyvinyl alcohol, is that is a flake form. Now, thermo-processing, so we now go into the packaging end of all the different thermo-processing routes you've got, whether it be blown film, extrusion coating, injection molding, blow molding, all of those require at the beginning of that process a pellet that you can heat and melt under pressure so you can thermally process it. So the ubiquitous way that you introduce polymers into the packaging industry or into the different thermo processes is as a resin pellet, and that's what we produce, and that's the key difference, to answer your question, between us and polyvinyl alcohol flake you can buy on the market. So that's what we do here at our factory in Birmingham in the UK, is we take the raw flake, we put it through, we do our chemistry, and then we put it through a reactive compounding process, and we end up with a resin pellet that can be used in a thermo packaging process. Yeah.
And if you look at the final product, say you create a blow film, if you were to create a blow film, presumably if you can create a blow film from a regular PVOH versus hydropol, would there be a difference in the properties as well, or it's just not possible to create a blow film from a flake?
You need to do a co-polymer. And there are co-polymer, you're blending it with other polymers in order to make it thermally processable, and there are on the market, and they're regularly produced, and you see things like laundry bags being produced out of them, but which then you put your dirty washing in, you throw in the washing machine, and the bag disappears and you're just left with your washing. That's great, but it's still a copolymer. And what we do is do it without the other polymer in there. And that also enables us to have a higher level of functionality, because the copolymer reduces the functionality out of necessity because you're adding that other polymer. So you've got that blend of the two polymers functionality, whereas the pure PVOH version we have gives you that higher functionality. But if you look at two pieces of plastic, back to the supermarket analogy we're talking about, to the average person, understandably walking around, they just look like two bits of plastic. You wouldn't know what the polymer is or the different blends of polymers. So it's really how it behaves from a functional point of view when you do that barrier test, or you put it on that shelf life trial, or you try and break it down at the end of life, that makes a difference. And that then sort of brings us into the complexity of why polymers are so hard to recycle and why so much packaging, we have such a problem with polymers, is because most are a blend of different polymers. Either they're constructed in different layers, or one's coated on top of the other, or they are actually physically blended like that as a copolymer, as an alternative to hydropol.
So one of the challenges you and I both know about packaging is the challenge is so large and you need scale. And when I'm listening to you, I'm feeling that that's possible in this case. You said, there's millions of tons produced of PVOH, if I heard you right. So do you think that something like maybe Hydropol or Aquapak's new products that will eventually evolve, do you think it could be done at a significant scale, that it can make a dent in that huge pile that we've created?
Absolutely. And we're not the silver bullet. We're not saying, hey, stop everything, let's all just do hydropol. We're just one of several new entrants and new materials that can be part of the solution. I guess my key message is, we need new materials. We can't solve the problem with what we've always used, because otherwise we wouldn't have a challenge. So it is a common, but equally those are not bad. They just need to be used in combinations with the right new materials in order to design them. Again, you can't lose the functionality. None of us are going to move away from products that aren't convenient or aren't safe or don't arrive on our doorstep the way we want them. So we've got to start there. You've got to have the functionality, but you've now got to design in, which is only in the last 10 or 15 years we've even been thinking about this, how you actually separate and sort and recover those materials at end of life, so you don't have to chuck them away or waste them. Now, of course, there's a finite amount of times that you can recycle a polymer, but it's better to get 3 or 4 lives out of it than 1 life out of it. And at the end of that, there is some form of energy recovery you can still get now, because clearly a lot of copolymers or coex or different combinations of polymers are being incinerated, which is probably better as an energy recovery than putting it straight into landfill where there's a whole lot of other inherent products. But let's not go down that debate. Let's focus on how do we keep those materials in the economy, otherwise known as a circular economy. Even if it's for 2, 3, 4, 5 or 6 iterations, let's focus on that. And that really is about using all the tools in your toolbox that you can to design products that are functionally correct to meet the needs of the consumer or your customer, but enable you to break down and separate. And that can absolutely be done at scale. But to your point, let's just give it a little bit of context. There's 400 million tons of polymer being produced annually globally. I mean, try and get your head around that. That's such an enormous figure. So we could all go away, that's far too big. We can't cope, where do we do? But it is just back to that, just get started. Biopolymers right now are 2% of that. We've got started, great. Things like PLA and PHA for certain applications are fantastic. You've got products there that you can compost. Yes, we need more composting facilities a consumer can actually access and put it in, and most can't at the moment, so that's problematic. But it doesn't mean you shouldn't be doing it or trying to do it. And that's a good way to think about it, because then we can start doing other stuff with a similar can-do mindset. And consumers, I think, and I'm a consumer too, we're all consumers, are looking for that and thinking, it's nothing more frustrating when you get a product, you look on the label and it says don't recycle, or recycling currently not available. What does that mean? We all want a solution because we're all aware that we've used something for a very short period of time and now it could potentially be hanging around the environment for 4, 5, 6, 700 years. and just putting that straight in a plastic bin liner and watching it go into landfill doesn't make anyone feel good. So how can we actually do something with that which at least enables that product to be sorted, separated, and recovered? And that comes back fundamentally to packaging design, which comes back to your question around scalability. We've built a factory with 40,000 tons of capacity here in Birmingham, which in 400 million tons is a drop in the ocean. But you combine that with other materials, it starts to have an impact in 1 or 2 different formats, 3 or 4 different applications. We can build, we can scale to any size you want to, because the raw materials, I've said, there's 8 to 10 million tons. You can make more of that. There's probably only 1 million tons of that actually available, that isn't being used for other sources, because PVA is being used for things like paper making. It's been used in your car windscreens and PVB and stuff like that. There's a lot of industry, but you can scale that up when demand starts, and we can scale up with it. Our compounding capability, we just buy more compounders, and we can scale with that, and we can grow. And to be taken credibly in this business, because the numbers are so enormous, you need to have actual scale. You can't just be a good idea in a lab, because then you're just a good idea in the lab. You need to physically prove that you can make this stuff at scale, you can supply it at scale, and your customers can make it at scale. And that's where we are now, and that's been a long journey, and it's a journey that will continue as we evolve. Every iteration, every new version of our material will just get better or extend into new thermoprocessing routes or new markets. But we're not the only one. There's several other people doing that, but it is the combination of materials that enable you to design products that are better. And that's what we're trying to do here. We're just trying to do something that's better than it was yesterday, and we'll get to perfection, and eventually we'll tackle the mountain, which is what you started your question was about 7 minutes ago, which was it's so big, can we actually rise to the challenge? Yeah, of course, but bit by bit.
And 40,000 is a decent scale. It's not small by any standard, especially considering the biomaterials economy. And we get to hear of lots of seaweed, but then when I talk about scale, it's like 3,000 tons and 5,000 tons. And you're right, it's not going to be just the 40,000 tons, it's the combination of products that is going to come out of that, which is going to be also the ultimate weight is going to be higher. But just for my understanding, for a consumer, from a consumer's perspective, does it look exactly like plastic, or do you make a difference in that so that the consumer, apart from reading the label, can make a choice that this is not plastic? How do you work that out?
Wow, that's a really good question, because I think first there's a sort of fundamental question within that is that the consumer's job to identify and work out what to do with the product? Personally, I don't think it is. I think it's our job. That's all our expertise is. That's the service we're meant to be providing as an industry, to give the consumer something that they get their product, they can use it, and they can really easily recycle it. And I think if you're going to get the maximum impact, you want to make that as simple and accessible as possible. Just put it in one bin, because the technology exists to do the rest. We don't need to go and educate everybody in every country in every language to say, right, you need this color bin and that color bin, and you peel this up. We just need to use the technology that's out there, and there's some fantastic technology that the recyclers have at their disposal, and in some cases they're already using. But what is missing is the economic drivers for them to want to continue invest in that, because we're not placing enough value on the actual recycled material. And the fact that virgin material costs less than recycled material in some cases is not going to incentivize them to invest in it. So my view is we need to find a way of making the economics stack up, so you can encourage more recycling, and that there's a pull from the industry to actually not just be waste management in moving waste around, so you put it in a hole in the ground or you put it into energy recovery and incinerator. You actually want that material back, and you can then sell that material back into an industry so it is repurposed and reused. And I think consumers obviously got a huge part to play in that, and certainly their buying power, I think, will incentivize companies to do more of that. And collectively, I think investors and consumers can really make that happen. But the industry needs to invest in greater capability to do that rather than relying on the consumer to make that choice.
And you're right, as segregation technology evolves, and hopefully they should be able to differentiate between the products, and then hopefully there would be enough robots to do the segregation, and you don't need humans to do that. What about, Mark, what about the cost? If I was to compare a fundamental basic plasticizer polyethylene film kind of an idea, flakes versus Hydropol, would you guys be able to, what would be the spectrum? How different would one be from the other?
Well, we're not the cheapest and we're not the most expensive. That's a very broad answer. So, yeah, we're compared to a polyethylene, which is the most used, the most ubiquitous, the most understood. People get bags, just a straightforward shopping bag made out of polyethylene. So everyone understands what that is. We're 4 to 5 times more expensive on a ton basis than that. But polyethylene has a very limited functionality. So when you start looking at materials or polymers that have high functionality, so let's take EVOH, very similar in chemistry to what we do. That's slightly more expensive than what we do, but it's or broadly around the same, but probably slightly more. But the functionality is very close. So we have an excellent oxygen barrier. EVOH has an excellent oxygen barrier. The difference is ours is dissolvable, enabling materials to separate, and EVOH isn't. EVOH you can use in very high humidity conditions. Hydropol you can't use in very high humidity conditions in certain structures. So there's no straight answer to that. And then there are polymers and specialty polymers that are way more expensive again. So there's a whole range, but really the factors that drive the cost on that are, one, obviously availability and scale, and as you have more volume, obviously the pricing dynamics change. But really then it's the equation between the functionality of the polymer, so what are you getting from that polymer, as well as the volume, the availability of that polymer, which are driving the price.
Right in the beginning, when you were talking about your first experience with Hydropol and the substance that you got and that tempted you to join Aquapak, you spoke about the strength properties. Let's talk more about that. How does that enable lightweighting for you? Can you reduce the overall cost of a product by using PVOH or Hydropol at a lower weight? Does that work?
Yeah, absolutely. And it comes back to why is plastics why is polymers being used? We started with metal and glass, and we've lightweight. But I think most consumers would be shocked to understand that everyday products they're taking off the shelf might be 9 or 11 layers of polymer in something that they can see through with print on the outside. They're going, what? How does that happen? But of course it's evolved that way because you need a sealing layer on the underneath, you need a barrier layer in the middle, you need something in there for strength, and you need something in to print on at the top. And then you might need something else in there for an oxygen barrier, something else in there for moisture barrier, and so it goes on. And so we have it's complex, very complex, and back to the chemistry, but we've evolved it in such a finite way because you ultimately end up with really good looking packaging, which does a great job at informing the consumer, and some of the printing on that, some of those labels are basically mini legal documents in a very small space. All of that has evolved. Again, we've gone from gravure to flexo printing, and it's no different in the way we've processed the polymers. So we're looking at even 3 micron of barrier film, even 2 micron of barrier film in the middle of that, which is giving you oxygen barrier. So constantly the industry is looking at lightweighting and improving and driving efficiencies. But there's no reason why you can't redesign those 9 layers into, say, 5 layers or even 3 layers if it does the same combination, and reducing it from maybe a 50 micron thickness overall to a 30 micron thickness. So long as it functionally does the job, you can take weight out and you can reduce the amount of stuff you have to transport around from a weight point of view, but you can end up with the same functionality. And that's exactly the way that we would encourage you to think about Hydropol. I've got this new tool that I can process within a coex structure, just like I mentioned, down to 2 or 3 micron that gives me the oxygen barrier, but also gives me the strength. So maybe I don't need that polyamide. Maybe I don't need that nylon. Maybe I can replace that EVOH. It's not one thing, it's a combination of things. But it is, what is the right combination? Because then you get into all the different aspects of whatever that application is, what supply chains it in, what humidities is going to be subjected to, what strength do you need, what oxygen barrier do you need. So you've got to take all those things into account. But there's thousands of brilliant packaging designers out there that do that every day. And it's just saying to them, here's another tool, here's another way of achieving that. Go and try a different combination and further improve what you've already created.
So you, like when I look at the Aquapak website and I'm talking to you, you focus a lot more on recycling versus compostability. Although when I speak to you, I realize that it is inherently compostable. Is there a reason for that? I understand your idea around circularity, but in the end, if it was to be composted, it would be fine as well, right? And so why is that you guys have taken a positioning of recycling versus composting?
So it's really about scalability again. I think composting has its place, and ultimately I'd say any food packaging or any that's going to be contaminated with food, we need some form of organic end of life for, and composting is a great one. But anaerobic digestion is probably an even better one because you can get energy recovery from that. But there's very little of it out there. I think there's some studies saying in the UK that 2 to 3% of the population might have access to home composting, and it's not a lot more that have access to industrial composting. So when you get your magazine in a composted bag, and my wife is a good example. I'm just picking her out because she'll go, look at this is great. I said, okay, what are you going to do with it? Because we can't access industrial composting where we live, and we don't have a compost heap. It goes in that black polyethylene bag, doesn't it? And then it's going into landfill. And sadly, that's what happens in too many cases. So it's about thinking holistically all the way through the value chain, from designing products that functionally work for you and doing the job to get the product to where it needs to be in the right condition. And then that it's going to break down in such a way or access the end of life which suits the material. And we focus on that because Hydropol we focus on recycling primarily because Hydropol, as a material that dissolves, can disappear effectively in a hot wash, which again all the recycling technology deal with that, and then your other layers can separate. Now we've done a lot of work to prove this out in paper recycling. So you put a Hydropol coated layer, extrusion coated onto paper, you've got a barrier layer, you're basically functionalizing the paper to give it a barrier. But as soon as that, and we formulate it in such a way that as soon as it enters standard paper recycling in a paper mill and a pulp mill, which is it, the Hydropol will dissolve out, giving 100% fibre release, and we've tested this a lot. All your paper fibre is therefore released back into the recycled system, and the Hydropol will pass in solution, so it doesn't disappear, it's in solution, into the effluent plant where it will biodegrade both aerobically and anaerobically. And that's what happens with our dishwasher tablets. We've been flushing them down our drains and our sinks for decades now, and big brands globally have been selling us to do that. So we know it's inherently safe, and we apply the same logic into paper recycling. But the key is the separation from the paper, the ability for those paper fibers to then be recovered and recycled, and the Hydropol to pass safely into the effluent plant where it biodegrades. So that's why, because we want to keep the maximum amount of materials in the circular economy, and the access to that, the easiest access to that is through standard recycling, where there is the maximum amount of actual capacity to handle it. And that's the main reason we would go down that route rather than composting. And also the fact that it's back to the economics of it. You want to keep, if you can, the materials in the economy, and hence the circular economy. I'm not saying there's nothing wrong with composting. Composting absolutely has its place, and as I said, for food waste products, or organic, some form of organic waste solution is the right way, and AD would be a great one. again, designing products which can cope with food waste. And that could be hydropol on a paper, but it could equally be a PLA, or it could be a PHA, or one of those other biopolymers.
That's very succinct. Thank you. And just the last bit on the product. So there are so many applications, and I'm sure you're excited more about some and maybe not as much about the others, or maybe you're excited about them all. But come out with maybe 3 applications that you really think Hydropol does well, and Aquapak would like to focus more and more on those.
Okay, so I've given you a lot of sort of generic stuff, but if you then take that through to an actual product, I'll start with paper because I've just been talking about it. Coating hydropol onto paper to functionalize the paper means you can do something with the paper that you couldn't do without the hydropol. Now, it's not, a lot of polymers are already coated onto papers, polypropylene, polyethylene, in order to give them functionality, and of course they're metallized as well. So you see that inherently, for instance, in a lot of snack products, or crisp packets, that type of thing. So we're looking at how could you use hydropol in combination with that paper to functionalize it to fight in such a way that the end of life of those product, whatever that product is, that currently is hard to be recycled or can't be recycled, you can actually make it recyclable again through separation sorting. So we're working with a particular brand and the manufacturer, the packaging manufacturer, all in partnership to create a crisp packet, which will be a paper, a world first, as in it will be a paper crisp packet, which the message to consumer is not this can't be recycled, it'll be put it in your paper waste. That's it, simple, because it will be recycled like paper, because the hydropol is going to dissolve off. So that's one product we're super excited about in the paper area, but there's a whole load of other stuff you can do with paper with the same principle, but that's just one example to answer your question directly. In the polymer space, it is about producing polymers in a coex format with running hydropol, much as I was giving the example earlier around using it as an oxygen barrier in there, but enabling that product to the end of its life to be flaked, put through a hot wash, hydropol dissolve out, and then those other materials can be recovered where they can't be recovered now. Now, of course, that's partly theoretical, but the equipment exists to do that, and you can do all that. So again, it's about creating products that are better for the future than they've been in the past. But what we do give is the same for the right applications. We give the same or even better oxygen barrier. So it's the same functionality. So using hydropol in a coex structure for a filmic structure would be a second one, and that can be done for any type of products that needs oxygen barrier. And then the third one, which we're also very excited about, and we're quite well along with, again, a number of brands, but also some manufacturing partners, is as a fibre and non-woven to create a dissolvable wet wipe. So a wet wipe basically that doesn't have environmental jeopardy, but also can't cause some of the infrastructural challenges that you have down sewers right now with things like fatberg, because there's already a flushability standard in terms of making sure a wet wipe breaks up. And wet wipe, there's a lot of talk about banning wet wipes, but I'm sure that's imposing quite a draconian way of imposing a lifestyle change on a whole load of people out there who rely on wet wipes, and I don't think that's realistic to do that. So again, it's the same. Let's actually just take on the challenge and design something which doesn't cause the end of life problem, but gives you the same functionality in life. So we've partnered up with a lotion company and a manufacturer to do that and create a dissolvable wet wipe. And we've still got to go through all the testing on that. But again, we're really excited that that is a possibility we've got our sights on, that we can go and create that. And hopefully those three give you examples of specifically, but also very broadly, how you can design hydropol into different products using existing materials to help create the same level of functionality, but better end-of-life solutions.
Now, that's definitely a wide spectrum and quite diverse in terms of usage, and definitely gives us very interesting ideas on the usage. And
can I just say that?
Please do.
Sorry. Just on your wide spectrum. Yeah, the thing for us is, and this is sometimes where it can be a little confusing, is just to be clear on that point. We're a polymer producer, so we produce the raw material. We work in partnership with the guys that then take that raw material resin pellet and thermally process it to make the products that I've just described. So the key there is the base technology of Hydropol as a resin pellet can be thermally processed down different routes. And 3 examples I gave you was 1, extrusion coating, so you're putting it through a flat die and it's coating onto the paper. 2 was in a coex, you're using it in a blown film bubble within the structure of a coex as a barrier layer in the middle. And 3 was as a fibre, and then you can take fibre combinations and make a wet wipe. But actually in this case, we'll do it through a melt blown process, so we'll go straight from a pellet into a melt blown wet wipe. So just to make the comment, and apologies for butting in, that it is the pellet technology, the raw technology, which is ours, but we then do work very collaboratively with the thermo processors who are our partners and our customers to create the end product. We don't do that. It's their talent that does that.
No, I'm glad that you butted in and clarified that, because I understood it, but I'm sure there may be people who are listening to this and may not comprehend the base product and how it is altered in different usages. And what about the acceptability? How has that been for you as Aquapak? Have the customers been receptive? Has that been a challenge? Where are you on that?
Yeah, I think it's always a challenge. Anything new is always a challenge because, it's not everybody that wants to be the pioneer, to be the first to go out there and say, hey, I'm going to give this a go. But the pioneers absolutely exist. There are innovators out there going to try stuff. You also need to try it in a safe way. You don't move your whole brand across to your product. You do it on a limited run or in a specific application for a specific product for a specific period of time, and you give it a try. And that's exactly where we are. I think an overall comment is everything takes longer than you want it to, or you think it's going to take, because there are so many iterations and there's so many things that are outside of our control or even our customers' control, which could be anything from logistics to supply chain issues to just getting line time or trial time or tests take time. And a lot of, as a new kid on the block or new material on the block, the tests and standards that are out there weren't designed for Hydropol because no one knew about Hydropol. So in order for people to understand what we've got, just like you said, tell me how it works in a moisture vapor environment of this, or oxygen of that, or a migration test of this, or a food contact of that. And these are all absolutely standard questions in the industry that you need to conform to. But we have to, because that's a language everyone understands, so they need to know how it applies. So those tests weren't designed for a soluble hydrophilic polymer, they were designed for other polymers. So that is a challenge, because if we were to write the test to prove certain things, we'd do it in a different way. However, we understand the industry has a common language, so we have to work with what's out there. So that always takes longer, but you have to not only get through them all, but you have to explain and demonstrate everything at every step of the way in order to make so that everyone feels they're on, there's a level playing field of understanding before you can just start deploying the inherent benefits of Hydropol in terms of its functionality and its end of life. So, but that aside, the vast majority of conversation we have are extremely positive. Everyone is hugely interested in the product. You just need to go through that route and those steps with everyone, because everyone's got the same problem, the same challenge. Then there's a lot of pressure to solve that challenge, whether you turn on the TV and you hear the commentary around plastics and polymers and packaging and recycling and the linear economy and circular economy. It's on everyone's lips. Investors are heavily interested in this. This is now a boardroom issue in most brands, so people are looking for solutions. But is the world now set on a particular way? No, people are in that phase of let's look at everything, let's understand it, let's see which way the rules and regulations and standards are going to go and the legislation is going to move, and we'll just bide our time as long as we can in some cases before we have to make a move. And so that is always a challenge. So it's for us, it's picking the pioneers, the guys in the industries and the products where probably have the biggest challenge, and helping them solve that challenge and getting our product out there so that we can start to build it as a mainstream product that is accessible to everyone down the routes that I've already talked about.
So this reminds me, my last chairman was a experienced and wise man like yourself, and and my wife calls me a delusional optimist. So he would warn me about this whole idea of things taking more time than what I imagined them to, and he would be right 10 times out of 10. And I would decide this time I'm going to prove him wrong, and then I'd go back to the board and say, "Yes, you're right. It didn't work."
Sounds like you and I are similar. Yeah, because until you've done the trial or the test, you don't know. Yeah? So,
yep,
and not everything, not every plan goes as planned, as we well know.
Yeah, and I'm going to take this towards a wrap with my three last questions. The first one, I was looking at your wide experience in different packaging domains, and I was fascinated by that. And I see that the industry needs more and more talent. So what would you say to students who might want to enter the packaging industry to get them into the industry? What would your spiel to them be?
Yeah, well, I'll try and keep it short because they probably hear too much of me. But I'm really lucky in this job, and this is one of the things I love about Aquapak and being a new entrant and doing what we're doing is we get to work with some supremely talented people. I'm very proud of the people I work with here. We're in a city, Birmingham, in the middle of the UK, very cosmopolitan city. So we've got people from all around the world. We speak over 20 languages here. And people come here for different, as I explained, I think there's a core motivation and want to come here. But a lot of them have come out of universities nearby. We've been lucky enough to find them there because we work with so many universities. Right now we're partnering with 10 UK universities on various different products, and we tend to work with them on their specialisms. So for instance, we've got 4 PhDs down at Portsmouth University studying the impact of microplastics in the marine environment. We already did a big study on that with Professor Theodore Henry up at Heriot-Watt University in Edinburgh. We work with Loughborough University on the adhesion and the adhesion of our product, affinity to other products. We work with Aston University on rheology. We've just kicked off a big project with Birmingham University where they're looking at the whole processability, and we just got a big funding program with them, and so it goes on. So we get access to a lot of students, so we're very lucky from that because we're sort of taking the fundamental R&D, and I often liken Hydropol and what we've done to a big jigsaw, and every piece has to be found, and some universities are just working on one piece for us, and that piece helps fill in the whole puzzle. So we've recently kicked off a thing with a program with Newcastle University Chemistry Department where John and I will be partaking with them, and I'm lucky I get to talk to 70 students, and I'll be telling them, hey, this is a great career, this is a great company. If any of you are interested, come and talk to us, but just don't limit it to Aquapak. There's a whole lot of other people like us out there, and so it's I am thankful that you get that opportunity, and because you're doing something different, and it does require you to work up and down the value stream. It does require you to talk to a whole range of different people. We can be talking to government one minute, or we could be talking to a PhD student or an undergraduate the next minute. It gives you that opportunity to actually always be out there looking for talent, but also hopefully enthusing people that, and I think, I don't know what generation we're in now that students are, but they think about careers differently. Certainly than when I was their age, how I thought about career, and I think they're more like-minded, shall I say, to look for businesses like us, and they want to be part of something that hopefully is having a positive impact. So a lot of what we say about that resonates, and then you can look at the specific talent that they can bring. So we've been lucky, and we've collected some absolutely fantastic talent here. But I think also our story and what we're trying to do really helps in that, and we do continually work at it.
Yeah, and I couldn't agree with you more. It's definitely a generation that is very purpose-led, and we find that as well. And I would definitely encourage you to mention your Good Garbage podcast the next time you are talking to students, because we realize that even our podcast, it's mostly that age group, the people who are looking at polymer sciences and packaging, and which is a great, fascinating, and encouraging thing for us, that students are interested in this packaging domain. And we get a lot of queries from, again, people who are studying in that material science kind of an idea. And I'm going to take it towards a wrap with my last two questions that I mentioned before. I'm keeping track of the last three. So it's amazing to see the kind of scale you're operating in. But if you look at and you mentioned scale a few times, and I did too, but if you look at a 5 to 10 year timeline for Aquapak, what would your dream be? What is the amount of material that you think you could influence in that time? And don't hold back. What would it be as a dream if there were no barriers?
Yeah, with no barriers, the way our product can be used, the way we're evolving it in terms of generations of the existing product, continue to improve it from a processability and a functionality point of view, combinations with other materials. In 10 years' time, we could be producing hydropol. My dream would be in millions of tons, because it can have that impact. It's certainly scalable to that level. And because we know we can make it at that level of scale, and you've already commented on how broad, even though I took it back into, it's the base technology that you then take down through all the different thermoprocessing routes. There's hundreds of thousands of those different thermoprocessing machines out there that all can accept pellets. Now, of course, you have to learn how to run a new pellet, a new technology, and you need to go through all those steps, which we do through our technical transfer. But all of that is available capacity to use hydropol in and on in combinations with other materials. So yeah, our dream would be we can access that in millions of tons, because we designed this business with scale in mind, because to make a real impact, you need to be at that scale in this industry. And you are only going to work with the big brands in the world if you can ultimately produce it at that scale, because that's the scale they produce at. And that's exactly how we've thought about this business from the beginning.
Yeah, that's so encouraging. And I totally agree with you. We were working with a company for the small shampoo sachets, the one-time use, and they needed 16,000 tons annually. So it's one little sachet, and that's the kind of tonnage we're talking about. So if we don't do it at scale, it's going to be it's the challenge for the customer would always be, how do you switch? So that's a huge challenge.
And we thought about that really early on, and that's why the key elements to us are available raw material, and hopefully I've already explained that is available and can be scaled if you need more of it, which we would do at that level. The fact that we're also looking at evolving our own source of raw material, albeit we'd license that technology out, and then our own converting capacity, and trying to keep that really simple with standard equipment that you can then process that. And that's where the scalability comes from, because we did the same calculation, and we're working with certain brands that are using even that one product in the billions of individual units a year, and we're working with them on redesigning that product. And I think this is mind-boggling on one side, but equally when you look at it from that point of view, you realize that having an impact is very accessible, because when you're in certain formats, those formats can be scaled very quickly. Of course, you need to go through all the steps and gates in order to achieve that, but they are being used at that level of scale. So you've got to be able to supply at that level of scale, or else you're always just going to be an interesting idea that will never be used ubiquitously, which our aim is to absolutely be used ubiquitously.
Yeah, and I think the idea of you can't challenge everything. So I like your thought process on not challenging the supply chain. You can use it in the same blow film machine as what a plasticizer would be used in, and you're going to give base material which can be used in multi applications, and that both those things are really important, I think, for scale. And that takes me well to the. And you can, of course,
again, I'm just going to bust
you're going to add something.
For the last time, you touched on a really good point, because I've not made it, because that scalability is absolutely right. And again, it comes back to the scale of the challenge that we're all facing. How do you actually make an impact, and where do you get started? And that was our thinking. Use existing infrastructure. One, in terms of thermoprocessing equipment. Two, raw material availability. And three, recycling capability. And that's why the first example I went to was paper, because paper recycling is the most readily available, and it's also a very vast scale. And so that's where we see a great use of functionalizing paper that can access that recycling. Sorry, I interrupted you.
No, you're good. Important points. There is. I think the interruption is important because these are solid points.
Kind of you to say so.
Okay, my last question, and I'd love to hear the answer from you. What does good garbage mean to you?
Yeah, well, I thought you might end there. So I'm going to talk about in life and end of life, and those are the words I use. So in life, good garbage is a product which has done what it was created to achieve. So it's actually made a product or a container, and we're talking packaging here, which has brought a product to a consumer safely, well communicated, in great shape. So it's done its job. But at end of life, it can also do its job, so you can actually access a way of sorting it and separating it so it can be reused and repurposed around the chain, and hence the circular economy. So effectively, good garbage is a product which is designed both to be used functionally in life, and so it can be recovered and recycled at the end of its life.
That's beautiful. Thank you, Mark, for all your amazing insights. I think the industry needs more and more seasoned packaging professionals who are fellow delusional optimists, who are ready to climb that mountain. Thank you for agreeing to be on the show. Thank you for the amazing work you and Aquapak are doing. I wish you all the very best, and I'm looking forward to you reaching 1 million tons very soon. Thank you.
I'll come and visit you when we do then.
Thank you for listening to the Good Garbage Podcast. Follow us on social media to never miss an episode. Links are in the description below. I'm your host, Ved Krishna. See you next time.